Our topic is projectile, and say that a projectile is a type of motion, or projectile motion is a type of motion in which a body covers both horizontal, the body possesses horizontal and vertical distances. So possesses horizontal and vertical distances. So horizontal distance, vertical distances. Now that's the first thing. And vertical distances, and it is under the influence of gravitational force. So you see a bullet, for example, you shoot a gun, you see the bullet, you shoot a bullet, it just goes straight, it goes down, you understand, somehow in this form, goes like this. We can say it's in this form, you understand, attains maximum height, then it now comes down in this direction. So we can say yes, it's a form of projectile, you understand. It comes from here, moves, goes up, goes down. So we can say this is a projectile form of motion. So the type of motion is known as a projectile motion. Projectile motion, you understand. So some examples, motion of a stone. When a stone is raised upwards, you raise a stone upwards. Now I talk about a stone. You raise the stone upwards, and if stone hits the target, then comes down, you understand. Motion of a long jumper, how a long jumper jumps up, then it now comes down. Motion of a javelin goes up, you understand, it goes like this, then it now comes down in this direction. So all these are examples. Motion of a bullet, motion of a grenade. So all these are examples of we'll call it examples under projectile motion, or examples of quantities that exhibit projectile form of motion. Before in this form, something like this, where I said it goes like this, then comes in this direction. We have something like this. Now we can say that this part is known as the range. This part is known as h. This h represents maximum height. Now this h represents maximum height, where this arrow represents range. So the range is like this, while the height is like this, you understand. So the height is going up, the range is coming towards this direction. So this part you see the projectile is following is known as the trajectory of the projectile. So the part, you can call it the path that a projectile follows. The path that we're talking about now is PATH, you understand. So the path that a projectile follows is known as the trajectory of the projectile. So the projectile, you see this shape now, this shape that is formed, or this curve that is formed, is known as a parabola. The part, or the curved part now, is a parabola. The type of motion is known as projectile motion, while the curve, or we can call it the path by which the projectile follows, is known as a trajectory, you understand. So we have talked about it exhibits a maximum height, you have the range, you understand. You talk about the curve is a parabola. You talk about the trajectory of the projectile, which is this curve, and the trajectory is also the path, which is PATH. H is the maximum height, arrow is the range, you understand. So this is the projectile. Now it's talking about the projectile itself. Now we have u, which is the velocity. So we can call this the u, which is the initial velocity, because that u is always the initial velocity. So initial velocity. Now we can be able to find uv, which is the u velocity, initial velocity of the vertical and the initial velocity of the horizontal. So we can find the initial velocity of the vertical, uv is equal to, now uv, so this is opposite over hypotenuse. Opposite over hypotenuse will give us sine theta. So opposite over hypotenuse give us sine theta. So that means uv is equal to u sine theta. That's the first part. Then for adjacent over hypotenuse, which is uh over u, which is cos theta. So therefore means that if we're talking adjacent over hypotenuse, we can now say that UH is equal to u cos theta. So we have said uv is u sin theta, uh is u cos theta. So that's the first part we need to know. Then also we have another part where we're looking for maximum height now. Now, when we are going to be looking for maximum height, we're going to say that we have different formulas which we are going to be checking out. We have the first formula, which is v equal to u plus at. We have v square equal to u square plus 2as. We have s equal to ut plus half at square. And we have the last one, which is s equal to u plus v over 2 times t. But the one we are going to be looking at, we're going to be using this equation, which is v square is equal to u square plus 2as. Now, you take note that at maximum height, for us to get maximum height, something has to exist. You understand? At maximum height, something has to exist. The first thing is that v equal to 0. That's the first thing. A equal to minus g, because it is working against gravity. So this is acceleration due to gravity. Then we have a equal to minus g, v equal to 0. Then the next part, s equal to h. So we're going to work with this. So from what we have, we're going to have 0 square is equal to u square minus 2gh. So from what we have, we're going to say that u square is equal to 2gh. So how do we get our maximum height? We can say that, firstly, take note that the issue on ground now, this u we are going to be using here for maximum height is going to be u equal to u sine theta. So we're going to have u sine theta square, because in this part now we use u sine theta for this. So at maximum height, remember that this is maximum height, right? For maximum height, where does it attain? It attains vertical velocity, and the vertical velocity is u sine theta. So in this place, we just replace it with u sine theta square. So this will give us equal to 2gh. So how do we get the maximum height? The maximum height h is equal to u square sine. Now sine theta is squared, so sine square theta over 2g. So the formula for maximum height now, maximum height is equal to u square sine square theta over 2g. That's the first formula. Then also for range, we're going to talk about range right away, but just take note that range is u square sine 2 theta over g. 2u, u square sine 2 theta over g. Let's check. U square sine 2 theta. U square sine 2 theta over g is what we have here. U square sine 2 theta over g. Then that we have time of flight, which is t, and we also have the small t. Now the small t is u sine theta over g. That's for the small t. But time of flight is equal to 2t. This one now, time of flight, we have the time of flight, and we have the normal time. So we have this t now is known as time. It's known as time. Why this one is known as time of flight? Time of flight. And this time of flight is almost like taking as the maximum time. So for the maximum time of flight equal to 2t, which is equal to 2u sine theta over g. 2u sine theta over g. Small t is equal to u sine theta over g. You understand? So time of flight is equal to 2t, 2u sine theta over g. So we talked about range. I would say range is u square sine square theta over g. You understand? Take note. We already know that range is u square sine 2 theta over g, but there is a point at which let's say, for example, the range is the theta here is 45 degrees. Now if the theta here is 45 degrees, that will call it arrow max. Now at arrow max, we have u square sine 2 times 45 degrees over g, and this will give us u square over g, because sine 90 will give us 1. So therefore u square over g will give us arrow max. So arrow max is u square over g. Take note. So if I look for the maximum range, maximum range is maximum range is u square over g. You understand? So just take note. There's even between the first one we talked about maximum height, where we said maximum height, the formula for maximum height is u square sine square theta over 2g. We talked about the range. We said range is u square sine 2 theta over g. We talked about the range, the maximum range, where we said the maximum range is u square sine 2 times 45 degrees over g, and the maximum range will give us u square over g. You understand? So the formula for maximum range is u square over g, but the formula for range is u square sine 2 theta over g. While the formula for maximum height is u square sine square theta over 2g. The formula for time of flight or maximum time, I call it maximum time, is 2u sine theta over g. Formula for time is u sine theta over g. So let's go again. Formula for maximum range is u square over g. Formula for range is u square sine 2 theta over g. Formula for maximum height is u square sine square theta over 2g. Formula for time of flight is 2u sine theta over g. Formula for time is u sine theta over g. With a velocity of 80 meters per second and at an angle of 30 degrees to the horizontal, the maximum height reached is. Now the first thing is, anytime in physics, the first thing you have to do is to write out your parameters. You understand? If you don't write out your parameters, you have a lot of challenges. So in this place here, you are given a velocity of u equal to 80 meters per second. They gave you theta to be 30 degrees. Now the maximum height reached, it told you maximum height. So just come here and say h is equal to, how do you calculate maximum height? To say u square sine square theta over g. U square sine square theta over 2g, or u square sine square theta over 2g. Yes, over 2g. So take note, u square sine square theta over 2g. So from what we have here, we're going to say u square 80 times 80 times sine square 30 degrees over 2 times g. You know g is 10. So what we have here is 6,400. Sine theta, sine 30 is 0.5. So what we are going to do now, we're going to multiply 0.5 by 0.5. And 0.5 times 0.5. So 0.5 square. Then 10. Okay, this will give us 20. So let's check what this is. So we have 6,400 times half times 1 over 20. So we have 0, 0, 2 year 1, 2 year 3, 20, 2 year 1, 2 year 160, 2 year 1, 2 year 80. So we have that h is equal to 80 meters. So check here, let's check if our answer is correct. So what we have here is 80. You see 80 meters here. And also come and check here, what's the answer? 80 meters. So just take note, it's not difficult.